Alright, my loves. This week we are looking at our systems of equations by graphing, and I also gave you that beautiful notes page. I gave you like the quick grab in the classroom if you were in the Monday, Wednesday group, but then I also made the nicer version for you. So just know that that is there. If you have any questions, please reference that. I also did put like the quick form notes up here as well. All right, starting off making sure that our equations are in y equals form, which they are. So we're going up to positive 4, plot, down to right 1, 1, 2, 1, 1, 2, 1. Start off with your 3 plot points. This one, we're going to change our color. We're going to go to positive 3. And we're going to go up 1 over 2, up 1 over 2, and cross. And this one does cross, but, ooh, my line is terrible. Let's try this again because that was a terrible line. All right, go back to green. We were at 3, up 1 over 2. So this one looks like it's going to cross at a non-integer solution. We talked about these a little bit in class, but this is crossing, but it is not crossing at one of our lines. So this is going to be a non-integer solution, or one that just doesn't cross at a whole number. When you see those, just go ahead and label it NIS, or non-integer solution. And that just means that although it crosses, it doesn't cross exactly at a number that's easy to read. So this is going to be a non-integer solution. Over here, we need to first put these in y equals form. So I'm going to subtract 3x from both sides. Negative y is equal to negative 3x plus 5. We talked in class about how we can't have a negative integer. That doesn't mean we're done. So we're going to divide the whole thing by negative 1. Y is equal to 3x plus negative 5. Over here, we can just kick the x to the other side and have y is equal to negative x plus 1. So let's start with our negative 5. And we're going to go up 3, 1, 2, 3 over 1, 1, 2, 3 over 1. Change our colors here. We're going to start at negative or positive 1, and we're going to go down 1, right 1, down 1, right 1, down 1, right 1. Okay. And, oh, I gave you another non-integer solution. These cross, but not in an exact line. Another NIS. Oh, goodness. I think I had a little too much fun writing these equations. Let's see. Hopefully we get back on track here. All right, I'm going to kick the 2x to the other side because I need to have it in y equals mx plus b form. This one is already there. So let's start with that one. Positive 2. And then x, which is just 1x. So up 1 over 1, up 1 over 1, up 1 over 1. This one we're starting at negative 4. So we might have to extend our line a little bit. Negative 4. And then we're going to go down to right 1, down to right 1. So let's see where these cross. This guy's going to be here. And this guy is going to be here. All right, I'll take it. We are at, I don't think I drew that very nicely. Let's extend it and not take a shortcut. All right, so 2, 1, 2, 1, 1, 2, 1, 1, 2, 1. Nope, that looks wonky. That looks wonky. It's hard to do the slope backwards. All right, down to right 1 would be up to left 1. 1, 2, 1, 2, 1. That still doesn't look right. Let's get a ruler. When in doubt, ruler it out. To be about there. That's better. And then this cutie. All right, this one looks a little off kilter, but this one does actually have a integer solution. This is going to be negative 2, 0. Don't mind my awful drawing. It really is negative 2, 0. I promise. And we can check it. This is a perfect example of where we should check it. So I have my X and my Y. Let's take this cutie. Y is equal to X plus 2. Negative 2 plus positive 2 is 0. The maths. If we put a negative 2 in here and a 0 in here, negative 2 times 2 is negative 4 plus 0. Negative 4 equals negative 4. See, I knew it was an integer solution. And that's how we could check. Put your X and your Y in, and if both the left and the right side are equivalent, we talked about that, and that's in your notes. If they're both equivalent, then you are correct. You're not cuckoo nuts. All right. Over here, I'm going to subtract 4x from both sides. Actually, bring it down here. I'm making a mess. All right, so let's give that top one space. 4x minus y equals 8. Minus 4x from both sides. Y is equal to negative 4x minus 8. I'm sorry, negative y. Divide the whole thing by negative 1. Y is equal to 4x plus 8. And then up here, we just have to divide the whole thing by 2. Y is equal to 3 over 2x minus 6 divided by 2 is 3. All right, let's go ahead and plot it. So we're going to start with the top one, negative 3. Plot point. Up 3 over 2. 1, 2, 3, 1, 2. Plot. 1, 2, 3, 1, 2. Plot. Let's see if we can. My lines get worse every time. Positive 8. And then down 4 over 1. 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. Oh, look, it's beautiful. Look it's beautiful. It's crossing at exactly 2, 0. And although my line is wonky, you can see that it's actually going to cross. So crossing at 2 and 0. All right, over here, let's do this cutie first. We're going to add 2x to both sides. 3y equals 2x plus 6. Divide the whole thing by 3. Y is equal to 2/3 x plus 2. Let's take this cutie down. 5x plus 2y equals 10. 5x from both sides. 2y is equal to negative 5x plus 10. Divide the whole thing by 2. Squeeze it in. Y equals negative 5 over 2x plus 5. All right, let's graph it. So we're going to start with this one. We're going to go up to positive 2. Plot point. Up to 1, 2, 3. Up to 1, 2, 3. And then let's go down here. So positive 5. Down 5 over 2. 1, 2, 3, 4, 5, 1, 2. Oh, I don't think that crosses at a nice place. Let's see. Let's see if the ruler can save us. All right, so we're going to put that in there. Terribly. We're going to flip it this way. And we're going to put this in. Yeah, definitely an NIS. NIS, non-integer solution. Oy, I think I went a little too cuckoo. All right, negative y equals negative x minus 2 divided by negative 1. Y is equal to x plus 2. And then over here, we just have to subtract the 2x. Just squeezing it in there. All right, so go up to positive 2. Up 1 over 1, up 1 over 1, up 1 over 1. Nice, neat line. Go up to 7. And we have a negative 2. So down 2 over 1, down 2 over 1, NIS. All right, you know what? We're going to stop here because that is 1, 2, 3, 4 non-integer solutions. So this is good practice. I want you looking for the integer solutions. So stop here. I'm going to rework the next couple of pages and see that I didn't give you 909 integer solutions, but this gives you a start. All right, I'll be back.